This is video number 5 of my series on the signaling system as I've implemented it on my layout. I just wanted to say a few words about that system. You can read a whole lot more about it in Model Railroader or in Bruce Chubb's series of books. The system I used is called Absolute Permissive Block, or APB signaling. APB signaling is mainly used for single track railroads. The purpose of this signaling system is twofold. The first is to prevent rear-end collision. So it will prevent one train from running into the rear of a second train. Casey Jones would have liked that. The other thing that it prevents is it prevents head-on collisions by not allowing any train to leave a station with a passing track unless there's a clear path all the way to the next passing track or station. This is all implemented in basic code, in the basic language written by Bruce Chubb in his series of books. I converted it to Lua, which is the scripting language that I use in my RTC program. So you can see that the Lua code in RTC is controlling all of the LEDs in all of the signals around the layout. It's called absolute permissive block because there are two types of signals that are used in this system. One is a set of absolute signals and one is a set of permissive signals. The permissive signals are suggestions. They are red, yellow, and green for stop and proceed, approach, or clear. The engineer takes that as a suggestion and adds his knowledge on top of that to decide whether he needs to go on or not. The other type of signals are absolute signals. Absolute signals are the signals at the exits of all the passing tracks. Absolute signals are indeed absolute. They are stop signal, approach, and clear. So approach and clear are the same as for permissive signals. The absolute stop signal, the red, is, as it says, absolute. The engine is required to stop and not pass an absolute stop signal. On my layout, there are only 6 absolute stop signals. I have 3 sidings. There's an absolute signal on the exit of all 3 ends of those 3 sidings. In addition, in his code in his book, Bruce added 2 enhancements to this system, which are actually real-world enhancements. One is called approach lighting. So in the real world, the railroads don't like to A, waste electricity, and B, waste lamp light for the lamps in their signals. So they're set up to only actually light the signal if there is actually a train there to see it. If there's no train in the block, the lights are off. Now I don't have that turned on right now, so if you look at my layout right now, all the signals are lit up. But the approach lighting cuts down on the amount of light generated by quite a lot. The other thing he added, which I also added, is being able to make headway. I mentioned to you that one of the things that this system does is prevents rear-end collisions. Well, it prevents rear-end collisions in 2 ways. One is it doesn't let one train get anywhere near the rear end of another train, or it can allow that second train to make headway against and up to the train ahead of it. So if 2 trains are going in the same direction, the second train can actually cozy up to that first train and get into the block right behind it. Okay, so in the next video, I'm going to restart the whole layout, and I'm going to be running 4 trains at the same time. With 3 sidings, I've determined that 4 trains is the most that this size of a layout can handle at once. Otherwise, the passing tracks get all clogged up and the whole layout just comes to a halt.